Alrighty, welcome to the first video in the MCAT Organic Chemistry Review. We're going to start with Chapter 1. If you have the Kaplan books, we're starting with Chapter 1 Nomenclature. So we're going to start off with IUPAC naming. So the goal of this is we want to identify a parent chain, describe how numbers are integrated into chemical nomenclature, and then apply nomenclature steps. So first, let's look at the steps. So the goal is to name this compound with IUPAC nomenclature. So let me draw the compound. All right, that's the compound. So the steps say to, number one, identify the parent chain with the highest priority functional group. So what does that mean? So it says identify the parent chain. So the parent chain, also known as PC. So PC is equal to the largest carbon chain with the highest order functional group. All right? And so the parent chain is then used to identify root name / suffix. Well, let's not call it a suffix, but let's just call it the root. Because once you start adding functional groups, then you start adding your suffixes. So that'll give you your root. The highest priority functional group is the most oxidized carbon and will produce the suffix of the name. So basically, the most oxidized carbon will tell you the functional group. So let's see. So the highest priority functional group the most oxidized carbon. If there are two or more chains of equal length, then the more substituted chain gets priority as the parent chain. And we'll see some examples of that later on. All right, so number two, we need to number the chain. So carbon 1 is one that is closest to the highest priority functional group. So clearly here we don't have anything that's connected to an O, any heteroatoms, none of that. So we simply have a straight chain alkane. We don't have no double bonds. We don't have no triple bonds, no alkynes, no alkenes. We have a straight chain alkane. Okay? The most oxidized carbon is higher. We already talked about that. So let's start counting this. So let's see, we have 1, 2, 3, 4, 5, 6, 7. Now you could take this around, but anytime you take it around, it won't give you any more of the carbons. So you'd have to go 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. Okay, there's 7. So 1, 2, 3, 4, 5, 6, 7. But you have to then look, okay, well, if I start here, or if I start here, actually, let's see. So let's number the chain. But the thing about it is we need to put carbon 1 is that closest to the highest priority functional group. So basically what I'm trying to say is we need to assign a number to each substituent based on the closest to C1. So let's try 1, 2, 3, 4, 5, 6, 7. Okay, so our first substituent is on carbon 3, then we have on a 4, 1 on 5. All right, now let's number this a different way. Let's number it the other way. 1, 2, 3, 4, 5, 6, 7. Now we have a substituent on carbon 2, a substituent on carbon 4, and a substituent on carbon 5, and a substituent on carbon 3. So what that means is because we have a substituent closest to carbon 1, which is what we want, we are going to number it like this. So we still have a 7 straight chain, so this is heptane. You should already know what your like root names would be. That's not something I should have to tell you. It's a heptane. So we know it's a heptane because it has 7 carbons. So now we also have how many substituents though? We have 1, 2, 3, 4, and then there you go. So now we have to name the substituents. Let's go over some common alkyl substituents. Now these are common yield on MCAT, so make sure you know them. So the common alkyl substituents, we have the first one. The first one's going to be tert-butyl. Tert-butyl has an R group connected to something that looks like a chicken foot. That's tert-butyl. Then we have sec-butyl. That's sec-butyl. Then we have neopentyl. So whenever you see something that has the neo, this means neo refers to straight chain alkane or normal. So N, oh, I'm sorry, not neo. I'm sorry, not neo. That refers to N. We'll look at that in a second. So neopentyl looks like this. R, you see we have carbon 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4. Then we go to isopropyl. Isopropyl is very easy. It looks like a Y. 1, 2, 3. There's your 3 carbons for your propyl. Then isobutyl. Isobutyl looks like this. 1, 2, 3, 4. All right. So now let's go here and let's name these substituents. So we have here. Okay. So we have a methyl, ET, an ethyl, dimethyl. Okay, so now let's name this. Now, if this was just a straight chain alkane, straight chain heptane, this would be N-heptane. Okay, and N refers to straight chain alkane. So we have a methyl on carbon 2 and 2 methyls on carbon 5. Then we have an ethyl on carbon 3 and an ethyl on carbon 4. So we know that ethyl comes before methyl alphabetically because E comes before M. So we're going to do 3, 4, ethyl, 4 ethyl, so I don't know if I want to give you the full like okay so we could do 3 4 diethyl okay 3 4 diethyl now let's account for our methyls then we have a 2 5 5 trimethyl heptane. Alrighty, so we have just completed the name. The next video we're going to talk about the hydrocarbons and alcohols.